Here we have y is equal to secant of x, and that's our specified domain here. So we want to graph this trigonometric function. So obviously we know that y is equal to secant of x is really just y is equal to 1 divided by cosine of x, right? Because these are inverses of each other. So when we graph this, there's some concepts that you want to keep in mind, like cotangent of x and tangent of x. For secant of x, you will see asymptotes. Obviously for sine of x, cosine of x, there were no asymptotes, but for secant of x, there are asymptotes that you want to consider. So let's graph this. So we have our x-axis here, we have our y-axis here. Just make that longer. Okay, so we have this, and again, we want to split this into 4 intervals, right? That's easy. So we have 0, we have pi over 2, we have pi, right? And then we have 3 pi over 2, then we have 2 pi. So we have our four intervals here, right? And so the first thing that I think you should also do when you're graphing such inverses, like for instance secant of x, is for cosine of x, try to just graph your cosine of x function. That's how I would do it. And so if you can graph your cosine of x, I recommend that you do that first. Let's just do that quickly. So cosine of 0, right? That is 1. Cosine of pi over 2 is 0. Cosine of pi, right? That's negative 1. So obviously this is 1, this is negative 1. And then 3 pi over 2, right? Cosine of 3 pi over 2, that's 0. And cosine of 2 pi, that's 1. So obviously we have that V-shaped curve over here. Now what's important to understand, right, or the technique, is that at points pi over 2 and 3 pi over 2, you see that your cosine value is 0. So we see that cosine of pi over 2 is 0. And then we also see that cosine of 3 pi over 2, that value is also 0. So we see that at those 2 points, right, the y value is 0. Our ratio here for that specific angle is 0. So we see that over here. And when we're talking about y is equal to secant of x, that's just really 1 over cosine x. So at those specific points, we see that, oh, it's just y is equal to 1 over 0, right? And 1 over 0 is undefined. Therefore, we have an asymptote there. So first, just sketch your cosine of x graph, and once you sketch that, then look for points where cosine of x is 0, and at those points, secant of x is undefined, or in other words, there is an asymptote at that point. So instead of, we can just... So we can obviously connect these points. I think that's easy because we know this is cosine of x. The next step would be for you, you just want to erase this, right? And you want to draw an asymptote here because you know that there's an asymptote there. So we have 2 asymptotes there, right? So we know that we have asymptotes there. Now the next idea, obviously this graph here that we have was the original graph for cosine of x. So when we were graphing secant of x, the technique really is wherever your graph is coming along, right, you want to draw an upside down shape, right? So what I mean by an upside down shape is, for instance, you see this graph emerging here, right, at this point. And so obviously at this point definitely does exist for secant of x, right? Because if you think about it, cosine of pi is negative 1, and secant of pi, right, it's just the reciprocal of that, which is also negative 1. So this is a point on the curve for secant of x, and the technique is you want to draw an upside down u here, right, an upside down u here, and obviously make that because these are your asymptotes, right? And you want to slowly begin to erase this cosine graph that we had, so you don't want to really confuse that. And then the other idea here would be, again, you would be extending this something, so it will look something like that, right? Again, this is your asymptote, and then this one would go something like that. So why is this happening? Well, if you think about it, your cosine graph was looking something like that, right? Something like that. And so when I said that it's gonna, so if your cosine graph was coming along here, right, then your secant graph at that point it's just gonna bounce back. Think of it as bouncing back. So if our cosine graph looks something like that, right? Well, this is bouncing back, so we know we must have something like that, right? It's bouncing back. Similarly here, if we continue this, it may look something like that. And again, you see that it's bouncing back. But obviously we're only going up to 2 pi. Here, it's bouncing back as well. So we have an upside down u here. We have this over here. We have this over here. And so now when we look at the negative pi over 2, so let's just do the negative pi over 2. And we have negative pi, we have negative 3 pi over 2, and we have negative 2 pi. So we have these 4 points over here, right? And really, if you think about this, so we have an asymptote at negative. So instead of let me make this a little bit more clear. So we have, as I said, we had something like that, right? At negative pi over 2, we also have an asymptote, right? So we have an asymptote here, right? And then obviously at negative pi, right? At negative pi, let me just erase this. And again, the reason why you're seeing this is wherever cosine, right, wherever your graph for cosine, right, is 0. So we know that when we're looking at cosine, the rule was that cosine of negative x is equal to cosine of x, right? You know that rule. So if you're looking at cosine of, for instance, I don't know. So you say something like cosine of negative pi over 2. Right, that's the same thing as cosine of pi over 2, right? So cosine of negative pi over 2 is the same thing as cosine of pi over 2, right? You know that because again, the first and the fourth quadrants, that's where it gives you the same value. So you know that cosine of pi over 2, is 0, and cosine of negative pi over 2 is also 0. Now if you know that cosine of negative pi over 2 is 0, well then at that point secant of x must be undefined. Therefore you have an asymptote there. So really, wherever asymptote you have an asymptote at pi over 2, you have an asymptote at negative pi over 2. You have an asymptote at 3 pi over 2, well then you must have an asymptote at negative 3 pi over 2, because really cosine of negative x is equal to cosine of x. So if you know that it's 0 at this and this, well it must be 0 at this and this. And if you have a 0 there, then obviously 1 divided by 0 is undefined. Therefore you have an asymptote at these 4 points, right? And so if we continue graphing this again, you have your imaginary cosine. Again, if you want, I can make that picture quickly. It's going to be the dotted line, so it looks something like that. And then you would have something thing like that. If that looks better. And so we're seeing that it's going to bounce back, right? The curve's going to bounce back. So you have it going like this, and then you have something, because this point is obviously going to be part of secant of x. So this is going to look something like that, right? And then you're going to have a point that is obviously, so you have a point here that's going to go something like that, right? So your graph really now, because it just seems to get confusing because of this dotted line here, but this dotted line is really a cosine of x, and that's just to help you there. But you see that you have a upside down u over here, right? You have a u here again because these are the asymptotes. You have your 4 asymptotes over here, right? And at negative 2 pi, if you think about it, cosine of 2 pi, right? That is 1. So cosine of negative 2 pi must also be 1, right? And if cosine of negative 2 pi is 1, right, secant of negative 2 pi is really, it's also just 1. So we obviously know this is 1, right? And then we're obviously just continuing this in this direction. So this is obviously 1. The y value at this point is 1. So obviously you can, take cosine of these values and then just do the reciprocal in your mind to see if you did everything correctly. But the best way to sketch a graph, right, is to make that upside down or bouncing back shape at that point, because obviously those points do exist even for secant of x, because really cosine of x and secant of x are just reciprocals of each other. So your graph looks something like this, right? So you have your u here, You have a shape here, you have something here. Again, it's restricted within 2 pi. And that's why I'm saying, like, you need to understand those techniques, right? Exactly how you plot them. Understand that cosine of x is undefined, right? Well, cosine of x is 0 at pi over 2 and 3 pi over 2. Therefore, secant of x must be undefined at pi over 2 and 3 pi over 2. You can plot your asymptotes. And then obviously if you have something that's more complicated, like a translation, secant of x plus 4, then you want to move that graph 4 units up, right? Or if you have 2 times secant of x, then you know that's a vertical stretch by a factor of 2. And then obviously you can plot points in. And really, if you know your reference angles and you know those ratios on the unit circle, then it shouldn't be quite bad translating your graph. So this is how your secant of x really looks like. X-intercept here clearly does not cross your x-axis here. So your x-intercept is none. Your y-intercept is 0, 1. Your domain is obviously the set of all real numbers, again, within this specified domain, such that x does not equal to pi over 2, 3 pi over 2, negative pi over 2, or negative 3 pi over 2, again because you have asymptotes there, and your range is y is greater than or equal to 1, or y is less than or equal to negative 1. And you see that negative 1 is being hit by these 2 points, and then everything else is less than negative 1. 1 is being hit by these points over here, right? And then obviously the other y values are going to be greater than 1. So that's the graph for y is equal to secant of x. It is a little bit intricate here, but as you practice, it will become easier. So thanks for watching.